Okay, so we've decided that we are going to do a fun lab on Thursday, and so the requirement then is, because we've decided this, is everybody must bring a 2-liter drink bottle, empty and clean. Okay? Got it? Don't bring any nasty old dirty drink bottles. All right. So our problem we're solving now is this one. If an enclosed gas in an expandable container has 92.78 milliliters of nitrogen gas. Hey, that is a what? What dimension of measurement does that fit? 92.7 milliliters. What does milliliters measure? Volume. So we got a volume. 92.78 milliliters. Okay? And at 300.0 K, what dimension of measurement is that? Temperature. And the temperature's increased. Uh-oh, we got a second temperature. How do we differentiate this temperature from the second one? Or T2. Yeah, that's fine. Okay, and so that's 350.0 K. What will the new volume be? Oh, we got a beginning volume and an ending volume, so we got to differentiate those. What are we going to call those? V2, we don't know. V1 up here. Okay. Wow. So let's see. We got a list of knowns and unknowns here. What equation does that fit? That. Charles' law. I mean, how much easier can I make it? V1 over T1 equals V2 over T2. Okay? You have to write the equation. You have to write it out. All right? And then you substitute known and unknown values. All right? So V1 we know now is 92.78 milliliters. T1 is 300.0 K. V2, oh, we don't know what V2 is. So we're going to leave it alone. Okay, because we don't know what it is. T2 is 350.0 K. All right, next step, isolate the unknown. How do we isolate the unknown for a problem like this? Does everybody understand why we're doing that? Okay, so we're going to multiply both sides by 350 K. The reason we're going to do this is because that gets V2 by itself. Okay, it's isolated. But if I do it to this side, have to do it to this side. Whoops, that's 350 K over 1. And now we can do the math. But I can simplify everything by getting rid of K now. Okay. They've been awfully loud and rude, aren't they? You think? Okay, so do you get 108 something? And we've got a 3 that continues, so I'm just going to make it a 3 with a line over it to show that it's a continuous 3. Okay? And the units we have left are milliliters, and that equals volume. And here's the beauty of all this dimensional analysis stuff, is that the units of measurement we have left here matches the dimension of measurement we're looking for. And we know we probably set it up right. Of course, I need to round off now. How many digits do I need in my final answer? Cuatro. 4. For those of you who don't speak Spanish. I don't speak Spanish. I just happen to know cuatro means 4. That's about the limit of my Spanish language. Let's see. 2 milliliters equals volume 2. Really? Okay, that's an object lesson. You should always do your math twice. Okay? Really? And you still got the same answer? You have the same numbers I have up here in the same places? Bring your calculator up here. Can I clear all this stuff?
Yeah.
All right, do it the easy way. You got too much stuff in here. Why don't you clear all this stuff out?
It does. I don't really need to.
I do. Gracious, how many things do you have in here?
There you go.
How many equations do you have in here? All right, now, let's see what we get. Move this around a little bit so maybe you can see, everybody else can see what's going on here. Well, shoot, can't get both of them to work, so I can see them both. Here, I'll tilt it up. Try that. All right, so I get 350.0 times 92.78, enter, divided by 300.0.
I can't get that. Because I'll tell you what.
I don't want to know what you did wrong.
I
want you to do it my way. Because my way gets it right.
You said to do every step, so I divided the 92.78 by 300 first before I cross multiply. You said not to cross multiply.
Well,
so I had to round
the
it
simple way that I've asked you to do is multiply what's across the top equals and then divide what's across the bottom. But, you know, I'm just trying to help you out. All right. Any questions about that? Nobody has any questions. Now, here's something you need to know. You cannot solve for an unknown that's on the bottom of a fraction. Well, let me back it up. You cannot solve directly for an unknown that's on the bottom of a fraction. Okay? Your unknown, to solve for it, has to be on the top of the fraction. Does that make sense? Understand what I'm saying? All right. So let me give you a problem here, and I'm going to show you how you have to solve it when that sort of thing happens. Okay? Okay, so we've got a volume of 250.5, 5 milliliters. I'll just ignore that big squashy thing there. We've got a temperature of 325.5 K. And the container's compressed to 225.0 milliliters. So we've got a volume 1 and a volume 2 now. And what will the new temperature be? That's temperature 2 before the pressure starts to go up. So without trying to be too complex, when you initially compress a gas, you theoretically at least, and I think it would be fair to say it actually does happen this way, you first get a temperature rise, and then as the temperature equilibrates, the pressure goes up. We won't get into why that works, because that's really beyond the scope of the class, but that's why I worded it that way. So we have a volume and temperature relationship, so we can write this as V1 T1 equals V2 T2. When we substitute our knowns into this, we get 250.5 milliliters over 325.5 K, and then over here we've got 225.0 milliliters, the second volume, over temperature 2. And we cannot solve directly for temperature 2. We've got to somehow get temperature 2 on top of the fraction, not on the bottom. Well, here's the easy way to do that. Now, what we really are going to do is divide both sides by, take the number 1 and divide both sides by that number. But the result of that is what I'm going to give you. Okay? This is a shortcut that's allowed. If you do it to one side, you have to do it the other side. What we're going to do is flip it. Okay? Mathematically, it works out. I could show you the math, but the simple thing is we're going to say T2 over 225.0 milliliters. And over here, we're going to flip this side. If you flip one side, you got to flip the other side. So we're going to get 325.5 K over 250.5 milliliters. And that's how we're going to get T2 on the top. Does that make sense? And you can solve the rest. Okay? Multiply both sides by 225.0 milliliters. Okay, please solve that problem. Show all your work. And when you get everything done, this is the answer you should get. Down here at the bottom, 292.4 K. Okay? Everybody get that? All right. Let's stop recording this.